Section 2.4, average rate of change of a function. So we're going to go through this pretty quickly. A lot of it is going to sound like review with slope because we are talking about a rate of change, but just know there's also some basic calculus points that are going to be made in this little section of notes, but the biggest takeaway is that you know what the average rate of change is, and you know what net change is, and then just know that your quiz on this material isn't going to be on 2.4, it's going to start up at 2.5. So just a nice little piece of notes for some extra information. Okay, so this graph right here says the average rate of change. Well, we know that it's the change in y over change of x. Well, instead of saying y2 minus y1 over x2 minus x1, we're saying that point 1 is a and point 2 is b. So we're writing it in terms of a function. So f of b represents the y value of the second point minus f of a, the y value of the first point. Something else to note, the slope of the secant line on the graph of f of x connects those 2 points and those 2 out points. So that green line is your secant line. So if I'm asking, okay, well, what's the average rate of change of that blue curve of those 2 red dots? The line that connects the two is called the secant line. That's what we're going to find the average rate of change of. The other important thing to point out is net change. This is the two differences in the 2 points of the y values only. So in your homework, if it asks for the net change and the average rate of change, those are different. The net change is just the change in your y values, and then your rate of change is your y over your x. Okay, so here's our first example of a quadratic function. So it says find the average rate of change below. So since we're given the graph, we can look at it and say that where x is -2, we need to figure out, okay, well, that means that we need to find the output. Well, when I plug it in the function at -2, I get the output of 3. Then the output when I plug in -1, or when I look at it on the graph, is 0. So the average rate of change is going to be 0 minus 3 over -1 minus -2. So we have -3 over -1 plus 2, which is 1. So we have -3. So for B, same thing. F of 0, that output is -1. F of 2 gives me an output of +3. 3 minus 1 all over 2 minus 0. So 3 minus 1 is 2. I'm sorry. Let me start over. 3 minus -1. All right, so we have 3 minus -1, sorry about that, over 2 minus 0, which is 4 over 2, which is 2. Okay, so then we have something called the difference quotient. So all this is saying is, instead of saying that x is a number and we have another number for x, we're going to say let x be a, and then we have the second point, which is a plus h. So just like I just did, I'm going to plug in a plus h in up here to this function and subtract it when I plug in a, the second point. So here's the form. You see the formula below, but I'm going to plug it into the function that I circled, g of x, up top. So the function is something squared minus 1. And the first thing we're going to put in is the second point, which is a plus h. Then I'm going to subtract it from something squared minus 1, but now I'm just plugging in a. So then this is all over a plus h, which is the x value of the second term, minus the x value of the first, which is just a. So now we're going to expand and simplify. So when I expand this first binomial here, I get a squared plus 2AH plus H squared minus 1. And then I'm going to distribute minus A squared plus 1 all over A plus H minus A. Okay, well now we can start simplifying some things. So on the denominators, the a's subtract out. On the numerator, the a squareds do, and then the 1's do. So I'm left with 2AH plus H squared over H. And when I get this, I can factor out, they all have an H in common, so I can factor that out of the numerator. And now I can cross it off on the denominator. And my final answer is 2A plus H. Okay, let's do it one more time. But the second one is going to be with a linear function. So, H of negative 2 is 3 times negative 2 is negative 6, plus 2 is negative 4. And then H of negative 1 is 1. So we have 1 minus negative 4 over negative 1 minus negative 2, which gives me 5 over 1. So my answer is 5. And once again, I'm going to correct myself. This output is negative 1. So I have negative 1 minus negative 4 all over negative 1 minus negative 2. Sorry about that. So I have negative 1 plus 4, which is 3, over negative 1 plus 2, which is 1. So once again, we get 3 as our final answer. Okay, let's see if I can do this next one right. Alright, so I have H of 0, which is 2, and then I have H of 2, which is 8. So when I subtract them, I have 8 minus 2 over 2 minus 0. 8 minus 2 is 6, divided by 2 is also 3. So if we do the quotient function, again, for the one that you see above this linear function, okay, so I'm going to have 3 times A plus H plus 2 minus 3 times A plus 2 all over A plus H minus A. I'm going to distribute, and I get 3A plus 3H plus 2 minus 3A minus 2 all over A plus H minus A. And when we cross things out, the denominator A's go away again. My 3A's go away, and so do my 2's. So I'm left with 3H over H, so I'm left with just 3. So the takeaway for this, when comparing the two difference formulas that we just did, is the fact that the first one was a difference formula with a quadratic, and now we just did one with a linear function. So comparing the two, the answer for the other one was 2A plus H, and if we replaced A with X, it'd be 2X plus H, and H is a number. So we have a line, a linear function is left over. But when we do it of a linear function to begin with, we have a constant, which is just 3 left over. So the difference is we have a linear difference versus a constant difference. And again, you will do a lot more work with this in calculus.